Hi, Dr. Bear here, and I am going to help you make simple circuits in PartSim, and we'll measure them. This is for my introductory to electrical engineering class for non-electrical and computer engineers. So one of the challenges, as you know, is you don't have a lab. So we're trying to overcome that with this simulation lab. So you can do this without an account. You can save your circuits if you have an account. An account is free, so you can just click try it now. And to make a circuit, we're just going to go and use the generic parts. So here's a source. Let's pick a DC voltage source. Let's bring out a resistor. So we go to the passives. And I'm going to introduce an ammeter. So to change its orientation, I right click, rotate, but I want to make this go the other way. So I'm going to flip horizontally. And now I can connect the voltage source to the ammeter. We're going to eventually make this be a closed circuit. Just to prove a point, I'm going to bring out a second ammeter, rotate it. Notice the two ammeters are oriented in different directions. The last thing we need to run the circuit is to introduce a ground, so we need a port. This is actually one of the artificial things about this circuit simulation. I mean, this is a very good and powerful circuit simulation tool, but you have to have a ground, and in a real circuit, you don't have to have a ground, but that's okay. I need to set the value for this voltage source, so I'll put it at 9 volts, why not? And I can set this resistor to, let's make it 3 kilo ohms. Now I'm going to change this meter name. So I click on the meter itself. Let's make it MI, not M1, but MICW for clockwise current, because it's going to measure the clockwise current, right? So current leaving the battery is going to go clockwise into this red lead, right? The plus lead of the ammeter, and then out the minus lead. That same current is going to go into the minus lead of the next ammeter and then out. So let's designate this ammeter as MI. So we're measuring current, and then we'll put CCW. So counterclockwise, okay? So this would measure positive current flowing counterclockwise or negative current flowing clockwise. So that is to say, if a current were flowing counterclockwise in the circuit, this would register a positive current. But if current is flowing clockwise in the circuit, then this is going to register a negative current. All right, now we can run this. So to run it and see the output of the ammeters, we hit run. We take off the DC bias, click transient response, run. And we have two lines here. So the x-axis is time, the y-axis is current. Two lines. The upper one is MI, so it's I for current, and then MICW, that's the name we gave the ammeter. It's telling us that the current is 3 amps. It's a constant 3 amps. That's good. Our source is designed to make 3 amps. Down here it's negative 3 amps. That's the MICW. That's the clockwise current. So, counterclockwise current. Counterclockwise current is negative 3 amps, completely equivalent to a clockwise current of 3 amps. So let's see that again. This ammeter clockwise was telling us that 3 amps was going clockwise. This one was telling us that negative 3 amps was going counterclockwise, which is the same as 3 amps going clockwise. I'll just point that out. The first ammeter is inserted so that it measures clockwise current. The other one measures positive counterclockwise current. And then, of course, they have their directions, but their signs also help us determine what the real direction of the current is. All right, the last thing I'll do is we'll add a voltmeter, or maybe two, I don't know. Let's try it. We go test equipment, voltmeter. Put it in here, connect it. So we're measuring the voltage across the 3 kilo ohm battery. This is M3, so let's just run this. Transient response, Now it gives us a voltage axis and a current axis. So I have 3 lines. There's the -3 current down here, +3 current, and then 9 volts. So pay attention to the units and the axes that we're on. Maybe we'll add one more voltmeter just for fun. I'll go like this. We'll rotate it or flip vertically. Basically, we're reversing the direction of measurement. And then if I run, I'm a little surprised it's not showing me the -10 volts. Maybe it can only show so many. Let's try this. Okay, so I'm still a little surprised. I only see 1 voltage here. Let's get rid of this one and see what happens. Oh, look at that. This doesn't measure the voltage very well because it's still showing 9 volts. I would think that should be a -9 volts. So that's something to be careful about. It looks like we're measuring currents very nicely, but the voltage is not being very nice. Nonetheless, there's a basic circuit in PartSim. I've measured currents along with their sign. And one other thing to think about when you're building a circuit is that you build and test. That way you can make sure that it works, rather than you build a complex circuit and then find out it doesn't work and then you have to troubleshoot why. So build a little bit at a time and then test. All right, I hope you have a good day. Bye.